Today we're going to start looking at u substitution, but this time we have bounds. If you look at what's on the right-hand side of your page there on page 10, we have a definite integral. So there's set steps that I kind of highlighted or wrote down for you up here so you can follow along with them as I go through this. All right, so on the left-hand side, I'm just going to choose my u. So my u is going to be what's in the parentheses, which is 3x cubed plus 3. And actually, you know what? Let me just put that up here. I think that might be a little bit easier. So u is equal to 3x cubed plus 3, because obviously it would be the same on both sides here because it's the same exact question, except for the bounds. All right, so then my du is going to be 9x squared dx. All right, so now what we need to do here is on the left-hand side, I see that this matches my u. And if I also look on the left-hand side here, I've got 18x squared dx, but I have 9x squared dx as my du over here, so that doesn't match. So in order to make what I underlined right here and here match my du, I need to multiply by a 1/2 here, which means I need a 2 all the way in front. So that's going to give me 2 times the integral of u squared du. All right, now let's go over on the right-hand side. Oh, actually, you know what? Let's stick with the left-hand side. Let's just keep going with this. So then I'm going to bring down that 2, and I am going to have 1/3 u cubed plus c. And now I'm going to distribute that 2 through, so I'm going to get 2/3 u cubed plus c. And lastly, substitute the u back in, which would be 3x cubed plus 3. That's going to get raised to the 3rd power plus c. And there's your answer on the left-hand side. Okay, well, now really on the right-hand side, we're going to start off the same exact way as what I have right here. So I'm going to have the 2 on the outside because I have to multiply by the 1/2 on the inside. Now, I'm not going to write bounds, and there's a reason why I'm not going to, so just bear with me a second. And over here, then, I am going to have u squared du. So, starts the same, right? Now, here's where the difference lies. I have bounds. So I'm going to try to make this as easy as I can for you. There's 2 ways to do it. I'm going to pick the easier way. When you have changed your expression over here and put it in terms of u, we also want to change these bounds and put our bounds in terms of u. So really all that means is you're going to take this top bound right here, which is 0. And when I say put it in terms of u, just means plug it in here for my x. So I'm going to do 3 times 0 cubed plus 3. Okay? And so when I do that, do you see that my new bound then would be a 3? I'm going to do the same thing again with this bottom bound. I'm going to put it in terms of u. So in other words, I'm going to take this bottom bound and plug it in u. So I'm going to do 3 times -1 cubed plus 3. All right, when you work that out, do you see that you get a 0? Okay, now I just want to point something out. Everything here now is in terms of u. This is in terms of u, and these bounds are in terms of u. So this is where we're going to start to have a slight difference in our answer. We're getting there. So similar to what I have over there on the left, right, I would have 2, and I would have 1/3 u cubed. I wouldn't have plus c, because remember when I have a definite integral, I have bounds, so I evaluate at those bounds. All right, here's where it's different. Guys, you changed these bounds and you made them in terms of u. So that being the case, you don't need to plug your u back in like we do down here. Make your life easy. So now all I'm going to do here is remember when we integrate that we can always take a constant out, right? So also when we evaluate here, I think it's so much easier to take this 1/3 and throw it out here. It just, you're doing all this in your head, so for computation's sake, it makes your life a lot easier. So that's going to become 2/3 out here, and then all I'm going to do is I'm going to evaluate u cubed from 0 to 3. All right, so let's bring this 2/3 down. I'm going to do upper bound minus lower bound. So I'm going to plug in the upper bound, which is the 3, and I'm going to cube it, minus the lower bound, and I'm going to cube it. So that's 2/3 times 27, obviously minus nothing. And then when we work that out, that's 18, and there's your answer. All right, so if you would turn the page, and we're going to look at number 4 on page 11. I'm just kind of picking some that I think maybe might be a little bit trickier or whatever. Okay, so I see parentheses here, so that's what I'm going to choose as my u. So my u is going to be 1 minus the cosine of 3x. Now notice that I have bounds. Okay, so the derivative of 1 is obviously nothing, and the derivative of a regular cosine is negative sign, so the derivative of a negative cosine will be a positive sign, right? So this is going to be positive sine of 3x dx. I can't fit the x at the end there, but that's a dx. Don't forget, though, to multiply by the derivative of that 3x, so that would be a 3 here. All right, so let's compare, because here's my du and here's my du. Do you see that I'm just missing right here? I need a 3 here. So if I need a 3 there, that means I'm going to need a 1/3 there. Okay? All right, let's keep going. So that's going to give me 1/3. Now remember, we change the bounds. So we're going to take this pi over 6, and we are going to plug it into u. And then we're also going to take that 0 and plug it into u to get new bounds. All right, so let's see what we have here. So pi over 6. If I put pi over 6 here, 3 times pi over 6 is pi over 2. And the cosine of pi over 2, which is the cosine of 90, is 0. And then 1 minus 0 is 1. So we got a 1 there. And we're going to do the same thing again. I'm going to plug in 0 here. Well, 3 times 0 is 0. The cosine of 0 is 1. And then 1 minus 1 is 0. There's your new bounds. And then we have, we just have u, right? u du. All right, let's do this. So I'm going to integrate that. That's going to be 1/2 u squared, no plus c because I have bounds, from 0 to 1. I'm going to pull that 1/2 out, so I'm going to make that 1/6, and then I just have u squared from 0 to 1. Remember, it's upper bound minus lower bound. So when I plug in the upper bound, I get 1 squared, which is 1, minus, and the lower bound, which would be 0 squared, which is 0. So my answer is 1/6. All right, number 6 on the same page. So my u would be 9 minus x squared. It's in the denominator, and it's underneath the radical. And my du would be negative 2x dx. Hopefully you see that the numerator needs a negative 2 here, which means I need a negative 1/2 there. So I have negative 1/2, the integral. I'm going to plug in 9. Now I'm going to plug in 9 into u, and I'm going to plug in 0 into u. All right? Okay. All right, I'm going to make one change. I don't want this top bound here to be a 9. It's not going to work out pretty. So what I want you to do on your paper, would you please make that a 3? Okay, because so now I'm going to plug in 3 here, which make that really easy for you, right? Okay, so again, I just want to change this and make that a 3. So that would make my top bound a 0 when I plug it into U, and my bottom bound is going to be a 9 when I plug that into U. And then I essentially have du over the square root of U. All right, so let's make that negative 1/2, the integral from 9 to 0, and that's u to the negative 1/2 power. Oh, well now looky. What do we have here? Does anybody see what Miss Carter sees? These bounds are not correct. Well, they are correct, but they're not correctly placed. My larger number should be up here, and my smaller number should be down here. So I'm going to switch these, and I'm going to negate this while I'm at it. Okay? All right. So that's going to make that 1/2 the integral from 0 to 9. And then here we go. Yeah, u to the negative 1/2 du. Now let's integrate. Okay, so that's going to be 2u to the 1/2. We don't need a plus c. Oops, and let's not forget my bounds here from 0 to 9. I'm going to bring that 2 on the outside, so 2 times 1/2 just cancels out. So I just have u to the 1/2, and we're evaluating that from 0 to 9. Now remember what the 1/2 power means. That really just means the square root of 9 minus the square root of 0, which is 3. All right, so turn the page, and I am looking at number 10, and I just kind of started it for you. This is on page 12. So I don't think that you would really have any issues with what I've done so far. So my u and my du, I needed to multiply by 7, and so I have a 1/7 on the outside. All right? Okay, so let me put this 1/7 there on the outside. I did not go so far as to change my bounds yet, because I wanted to have you be present in that. So when I change that, that's going to become 21. And when I throw that in there, that's going to stay 0. Alrighty. So this is going to be u to the 3/2 power, multiply by 2/3, no plus c, evaluate from 0 to 21. And let's not forget that we have that 1/7 on the outside. Now this is definitely a case where, like I said, do not even try to do this with this 2/3 staying in here. So I'm going to bring this outside. So that's going to become 2 over 21 on the outside of that. So 2 over 21. Then I'm going to do 21 to the 3/2 power minus 0 to the 3/2 power. Well, we know that 0 to the 3/2 power is just 0, right? So 2 over 21. Now I want to talk about this 21 to the 3/2 power. Remember that this is the power and this is the root. Power over root, power over root. So I'm going to simplify this a little bit. The root is a 2, so that's a square root, right? You don't have to put the 2 there, but I'm just showing you. And then that's 21 to the 3rd power. You can write it like this if you so choose. And this could be your answer, or if you prefer, you can do 2 over 21, square root of 21, and you can put the exponent outside parentheses like that. That's also okay. That's up to you, whichever way you prefer. Okay, look on page 13, and we're going to do number 14. So like the last one, I just took the liberty of starting off the u and the du and what I have to multiply by, okay? Because that 8 needs to become a 2, so I need to divide by 4, which is the same as multiplying by 1/4. So I need a 4 on the outside. So that 4 is going to be on the outside. Now remember, I'm going to change my bounds, and they always go into the u. So I'm going to put a 1/2 in there. So 2 times 1/2 is 1, plus 3 is a 4. And then I'm going to do the same thing. I'm going to put negative 1 in there, which is going to make that negative 2 plus 3, which is 1. And then I have du over u, which is an ln. All right. So I am going to say that this would be the ln of the absolute value of u. We're going to evaluate this from 1 to 4, and then eventually we'll multiply this whole thing by 4. All right, so that's 4 times the ln of the absolute value of 4 minus ln, the absolute value of 1. Now, the reason why we kind of put the absolute values in here is because just in case, what if you had plugged these numbers into u and we got negatives here? If we had any negatives, we want them to be positive because we can't have the ln of a negative number. All right, now I hope that you remember that the ln of 1 is, ding, 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 0. So this disappears. I have 4. And obviously, I know that the ln of the absolute value of 4, well, the absolute value of 4 is just 4, so I can say 4 ln of 4. Now, I'm going to tell you on an AP, if you get this question, you probably won't see that as an answer choice. Remember I said to you earlier on, in this video or the one from yesterday, I really cannot remember, if you have a number in front that starts out as a power. So another way to write this would be ln of 4 to the 4th power. And 4 to the 4th power is 256. So this would be the ln of 256.